My name is Mary Spiro. I'm a science writer at Johns Hopkins University, just in case you didn't know. And yes, I have drank. I have consumed the Kool-Aid, and it is good. I'm here to talk, so full disclosure, I am going to talk from a scientist's perspective. I have a degree in journalism and a degree in biotechnology, so I know a little bit about what I'm talking about. But I am not working in a lab every day in nanotechnology. But I don't have a lot of patience for people who are trying to discover the seedy underbelly of nanotechnology, because I think we need to discuss nanotechnology with full information. So there are a lot of really safe and beneficial applications for nanotechnology, and we're going to talk about those. There are also some concerns that we need to be addressing as well. But I want to specifically talk about where nanotechnology came from to begin with. So the origin of nanotechnology, well, first of all, things like DNA and proteins and things like that naturally are at the nanoscale. But the technology part came in when this guy right here, Richard Feynman, gave his talk in 1959 about, which was called "There's Plenty of Room at the Bottom." And in that, he talked about how one day chemists and physicists and biologists would be able to construct tiny machines at the scale of atoms. And this talk predicted some of the nanotechnology that we actually have in place today. Another visionary was Eric Drexler, and he wrote a book in 1987 called The Engines of Creation. And in that, he used a term that was actually originally coined by the Japanese materials scientist Norio Taniguchi, which was the word nanotechnology. Drexler popularized the term nanotechnology, and he also was the first person to introduce the concept of a nano-apocalypse, in which the Earth is consumed by the gray goo and of self-replicating nanobots. So I haven't read, he's actually updated the book, and he has a 2.0 version that came out, and you can actually get that on the internet for free. I haven't read the new version yet. So what is nanoscale? I don't know how much that you know about nanotechnology, so I'll just give you a little bit of background on that to give you sort of a sense of the scale. Something that's that small is sort of hard to grasp. So if you start thinking about, okay, your pinky is about 1 centimeter in width, and then a freckle on your face might be about 1 millimeter in diameter. A bacterial cell, these guys right here, they're about 1 micrometer, but a nanometer is really just a handful of atoms. It's really like as small as something as a molecule of sugar. If that scale doesn't make sense to you, this one might help. It starts with a head of a pin, right? And it goes all the way down to a carbon atom. And so a nanometer is essentially about half the width of a DNA strand. So later, when you have time, you can calculate how many nanometers can dance on the head of a pin. So when you work at the scale of nanoscale, things get really weird. And this is, I think the guy who's going to speak after me is going to be talking about quantum mechanics. I don't know anything about quantum mechanics, so I'm not going to talk about that. But this is where our size-dependent properties really start to take dominance. And for example, so in stained glass, gold nanoparticles are actually what makes stained glass turn red. Another thing is silica, when it's in macro scale, is an insulator, but in nanoscale, it actually acts as a conductor. And cadmium, for example, if you put it into quantum dot form, if it's at slightly different sizes, will fluoresce different colors. So these sorts of things are very useful in the scientific imaging. So today, nanotechnology is found in a lot of different applications. We've got nanoparticles in cosmetics. We have them in military applications. They are in our cell phones, in our cars. Nanotechnology is used in everything. We even have stain-resistant nano pants made of nanotextiles. But the potential of nanotechnology has really sparked the creativity and the imagination of writers and screenwriters. One of the very first mentions of anything that was sort of like nanotechnology was in the short story by Arthur C. Clarke called The Next Tenants. And in this, he describes a machine that if the operator moves it an inch, the machine actually moves 1/1000th of an inch. And if you've ever seen one of these Da Vinci surgical robots, this is exactly what that thing does. The surgeon's hands can move at the macro scale, but the actual tools and instruments move at the micro scale. So it's not nanotechnology, but we're getting close. One of the very first actual mentions, though, of nanotechnology in popular fiction was Michael Crichton's 2000 book, Prey. Now, has anyone read this book? A couple of people read this book. I don't remember, why were they creating the nanobots in the first place? Do you remember why? No? Okay, I don't remember why. But anyway, what happens is they escape from the lab and they go into the desert and they start to evolve and they start to gain intelligence and they start getting smarter. And so the heroes in the book try to tag them with radioactive isotopes so they can track them back to their nest. And then suddenly, when they're trying to do that, the nanobots swarm and try to suffocate the scientists. And then suddenly, the nanobots become symbionts, or become sort of like parasitic entities inside of humans, and they start to reproduce that way. And the way they end up killing them in the book, it's a spoiler alert right now, the way they end up killing them in the book is they, because they're bacterially based nanobots, they release a phage through the sprinkler system, which is then inhaled by the humans, and that's the way they supposedly kill the nanobots. The interesting thing about this book is that it cites journal articles and white papers and scientific literature, so it might give the reader the impression that this might have some basis in actual science, when it really is just the writer's imagination. My boss, who is a material scientist, Peter Searson, he said, and this is, I quote, he says, "You tell those people," this is what he told me to tell you, you tell those people that the nanotechnology worked perfectly in that story. It was the artificial intelligence that made the nanobots attack. So really, it's the computer scientists and the computer engineers that we need to be worried about, not the nanotechnologists." Predating Crichton's book, though, is Neil Stephenson's book called The Diamond Age. This came out in 1995. This is a cyberpunk science fiction or speculative science book. It's something of a coming-of-age story set in a neo-Victorian society where nanotechnology is basically the basis of the whole economy. Unlike the Crichton book, though, it doesn't try to present itself as a scientific book. It's just sort of a visionary tale, but all visionary tales can sometimes become reality. And I think that's what we'll see in this next little clip I've got here. Fantastic Voyage. Okay, this movie came out in 1996 or 1966. So, what is that? Is that 35 years ago? 45 years? 45 years ago. But actually, some of the stuff that they show in the movie is sort of coming true. And in this movie, which we're going to look at a clip of it. You're going to help me with this. In this movie, we have a diplomat that's sick, and we need to help him out. And so what we're going to do is we're going to inject some physicians directly into his bloodstream, and we're going to help him out.
Contact Proteus.
The scientists have been shrunken to microscale.
Right.
And they're placed in a hypodermic needle. I love the little sensors that are all around him. And there's this very, very high, the medical markings there.
Inject.
Tracking post.
Oh, right into the bloodstream. And that's exactly where it is. All right, another movie where nanotechnology has shown up is Transformers: Revenge of the Fallen, and that is actually inspired a whole Wikipedia entry about the so-called nanoscience behind the different types of transforming robots. So the guy who writes this technology blog for the Baltimore Sun actually contacted me, and he wanted my boss, Peter Searson, to talk to him about the science. And of course, he absolutely refused and said it was non-scientific rubbish and he wouldn't have anything to do with that. So, and also, I mean, from the looks of the rest of the blog post, he wasn't able to get any comments from the people at the University of Maryland Nanoscale Center either. So suffice it to say, I suppose the nanoscience in that movie is not very realistic. But there are a lot of other places where nanoscience has shown up, and it's sort of, if you looked at the visual rhetoric alone, you might guess that nanotechnology is something that we need to avoid, that we need to be afraid of and concerned about. It all starts off like, well, we thought it was a good idea until somebody used our nanotechnology for evil. And I honestly expect that there's going to be a movie coming out of Michael Bay Studios, that's like, that is going to be the gray goo. And I think that a lot of people, I think it kind of gets into people's subconscious that maybe nanotechnology is something that we need to really, really be worried about. But there are actual risks with nanotechnology, and they're real and they can't be ignored. So, and the reason for that is because nanoparticles can get into your cells, they can get into your, they can cross the blood-brain barrier, and they can get deep into your lungs. And news stories like this from China are not, they're nothing to be ignored. They really make a huge impact, and negative news like that travels a lot faster than good news. So there are legitimate concerns about nanotechnology and about nanoparticles that are released into the environment and into your body. And scientists and engineers who work in nanotechnology need to take these things into account. There are a lot of organizations that are dedicated to, private and public organizations that are dedicated to the study of nanotechnology. I mean, the FDA, the EPA, the National Science Foundation, the National Institutes of Health, and some private companies are also, very actively looking at how nanotechnology is used and the toxicological impacts that it could possibly have. And a lot of people say that we're just really not doing enough. We don't really know enough about nanotechnology to proceed. So, okay, here is my shameless self-promotion. So, Johns Hopkins actually has taken a very unique approach in how they have been studying nanotechnology from the very beginning. They have invited everybody who has a stake in nanotechnology, including the people from the School of Public Health and the Applied Physics Lab and Arts and Sciences and all these different organizations, to study nanotechnology together so that they are simultaneously looking at the benefits and the risks at the same time. And what I wanted to do is I wanted to share with you some of the actual things that are going on in labs at Johns Hopkins with nanotechnology that may be reminiscent of some of the things that we watched in the movies. Okay, so the first thing we're going to look at are some self-assembling nano containers. And hopefully you can hear the audio that goes with this. These are made out of gold.
One way to create a box is to piece together individual faces. But it's much easier to create a single shape that can fold. In the lab, folding metal shapes are created using a computer chip fabrication technique. This means the shapes can be extremely small. 6 separate faces made of gold are connected with a material that easily melts. As the structure is heated, the softer material melts and balls up to minimize its surface area. As a result, the faces pull together and form a box. Not only can these boxes assemble themselves, but they can be loaded with a substance and controlled remotely. One day, the combination of all these techniques may lead to advanced medical treatments, for instance, the very precise delivery of a life-saving drug.
And that's one thing from the Griseus lab. Another thing from the Griseus lab that is just really fascinating are these micro grippers, and they're also working on, right now they're at microscale, but they are working toward making them at the nanoscale, that are actuated by either changes in chemistry, so pH changes, or they can be manipulated by changes in temperature. And this is an example of the micro grippers. It can go down and take a sample of tissue. So something like this could potentially be used for a minimally invasive biopsy sort of technique. So it rips off a little piece of tissue, And there you see it. And of course, this is also all done in vitro, so these are things that are far off from clinical applications at this point. Another lab is the Michael Yu lab. He's working on artificial collagen, which is at the nanoscale, and also pairing it with a nanoparticle to enhance imaging and also possibly deliver therapeutic drugs.
The basic structure of collagen is that it has this very unique rope-like structure. So there's 3 different strands that comes together and make a rope that is very unique to collagen. The collagen mimetic peptides are basically a mini collagen. It has the same propensity as a natural collagen to form a rope-like structure. So what we decide to do is use nanoparticle as an imaging enhancement. Since we know that these collagen mimetic peptide binds to the collagen fiber, we want to know exactly in which location, where do these mimetic peptides actually interact and which part of the collagen is it actually binding. And it's been known that tumor contains a lot of unstructured collagen. We think that these mimetic peptides could collect specifically on a tumorous tissue, and we should be able to image these tissues very early on. And we can go to another step, which is to attach therapeutic agent to the end of our mimetic peptide. Then this would be a therapeutic application.
And the final application I want to show you is something that is, these are in the chemistry lab of J.D. Tovar. These researchers are building organoelectric nanowires that could be one day used to repair damaged nerves.
What we envisioned in our lab is to model our materials after these plaques. Our new materials are made from basic biological building blocks and designed to self-assemble and form structures that are on the nanoscale. We designed them in such a way that any one molecule will begin stacking with other similar molecules and begin to form structures that resemble molecular nanowires. One of the applications we envision for our new materials is to try to reestablish communication between severed nerve cells. Nerve cells typically function by passing electrical signals between one another, and then when you sever that connection, so if you have a traumatic injury, if you break your back, sever your spinal cord, that communication is lost. And we've designed our new materials to both be electronically conductive and also biologically compatible.
So there are a lot of other applications being developed in Hopkins labs that are really kind of, they are, they are opportunities where people, taking ideas that came from these visionary thinkers like Richard Feynman and Eric Drexler, and even from the movies, and turning them into reality. One of the things that we can do as individuals, though, is and I don't think that anybody in this room is going to have that problem, but you should be able to understand the difference between what you see in the movies and what you read in a real textbook, or what you see even in the news. Recently, I came across this blog post by Hannah Waters at the IO9 website, and it discussed something that was really interesting to me about how writers intentionally may introduce errors into their work to lend them authenticity. But because you're a reader or watching a movie or whatever, and you're sort of kind of lost in that suspension of disbelief, you may forget that what you're looking at is a work of fiction. And Waters says in her blog post, she says, "The real reason for my discomfort was that these are exactly the kinds of facts that I would ponder over or retell at parties without remembering the source. And I would say, I can't remember where I read it, but I definitely read it somewhere. Then there was one thing I thought about that she says, until recently I hadn't really thought seriously about a different angle. What if I didn't know enough to pinpoint these errors? What if I instead carried them with me through life as fact?" And I think a lot of the previous speakers have also said this. It's like we really need to be scientifically literate to understand. So if you come across something about nanotechnology and you don't understand it or you want to know more, there are some really good, reliable sources, and I would recommend these 3 particular sites for questions, to answer your questions about nanotechnology risk. And I think that there is a lot of great potential with nanotechnology. We have to approach it in a risk-benefit kind of a way. And one day nanotechnology and things from nanotech are going to be part of our everyday lives. They are sort of becoming part of our everyday lives. A lot of these applications are really just still years away from clinical trial, but I wanted to share some of the things that we see in the movies, and then actually what some of the things we are actually doing, and hopefully enlighten you and discern fact from fiction. The end. Yep.
Are you aware of, or have you watched Lee Cronin's talk called Making Matter Come Alive, where he's trying to sort of assemble this non-carbon based life in the lab using these like complicated metal complex molecules?
Who is this? That's
Lee Cronin?
No, I haven't seen that. I haven't seen that. I did listen to Science Friday the other night, or yesterday. Did you guys hear that? They were talking about using DNA as a tool to construct nano machines and nano structures with DNA as the instruction method. But no, I haven't. I'll have to look into that. So Lee Cronin. Okay. Yep.
So was the point of your talk to console us with the current state of nanotechnology, or to frighten us? Because little robots that can be remotely controlled, running through the bloodstream, and little nanobots that can like chew off pieces of your tissue. You can see where that could be kind of scary.
Well, they're not. Yeah, and I that's what I wanted to show you. Like, what is really happening? They're not robots. I mean, they're not autonomous. Okay. So remotely controlled via magnetics, via temperature, via chemicals. I mean, there has to be a man-made component to whatever it is that they do, and that's what I'm saying is that they're not developing, nano structures with artificial intelligence, because apparently we need to be worried more about the people doing artificial intelligence. Okay, they're tools. They're nanomaterial tools. Way in the back.
So you mentioned several groups that were agencies that were talking about regulation and concern with these issues. Do you see those agencies, particularly the government type ones, taking evidence-based approaches, or are they taking fear-based approaches to regulation?
No, I think they're all taking evidence-based approaches because they're all also the ones that are paying my paycheck. I mean, I think they're definitely organizations that are science-based. So the FDA, National Science Foundation, National Institutes of Health, they want to know, they want to cure cancer, for example. The National Cancer Institute wants to cure cancer, but they don't want to kill you curing cancer. So, or they don't want to, we want to make stronger textiles, or we want to make lighter airplanes, but we don't want to do it in a way that is also going to create, we don't want to have another DDT situation on our hands. We want to be able to, and that's been the attitude with nanotechnology all along, is we don't want to relive the mistakes of the past. We want to make sure that we know that there are potentially hazardous properties to nanotechnology, but the very properties that make them potentially hazardous are the very things that make them potentially beneficial. So we have to be able to balance that, and I think those organizations are taking that approach. Yeah.
I think that the examples that you showed are fascinating in the videos, but I read in other places about hot water heaters for showers that would use nanotechnology, and uses of nanotechnology that are much more everyday, things that you could have in your home.
Mm-hmm. Like your silver coating in your inside of your washing machine.
Yeah, things like that. And I think that if people maybe knew more about those things, they might not be as afraid, because now they might see nanotechnology as only something that they don't understand. And if I think that people understood more that it can be part of their lives, and it can do things around their house, then they might not have such an irrational or immediate fear.
Well, I mean, do you think people have an irrational fear of an emerging nanotech?
I think that's
Yeah? Bruce does.
I mean, I really don't know. I mean, disagree with anything about the science behind it. But yeah, I do think that there's some people who are just immediately afraid of nanotechnology because it could go in and rip out parts of their brain.
Only if you tell it to. Yeah. But I mean, wouldn't it be great though if we had a drug that could cross the blood-brain barrier? I can't say that, and destroy a brain tumor.
Oh, of course. I mean, I agree completely, and that's why. I mean, I think that if people understand all the facets of nanotechnology, then they might be able to look at it with a clear head, and they'd be more willing to embrace the great things.
And I think that's what, I mean, I can put the slide back up again. I think those organizations that I mentioned at the end, especially the Project for Emerging Nanotechnologies, that's a completely independent, it's not a government organization, a completely independent organization dedicated to telling you where nanotechnology can be found. They have an iPhone app that's like, oh, does this sunscreen have nanotechs in it? I mean, it definitely has, they have applications that will help you understand where nanotech shows up in your everyday lives, and also is it good? Is it bad? Do I need to be concerned about this?
By the way, I must be just snarky.
I know.
Do you think that having one term for it, calling all of it nanotechnology, and lumping the benign material stuff like nanocoating to keep your pants from wrinkling, and using nanotechnology to maybe again cross the blood-brain barrier and attack a cancer, having that all sort of lumped together is what causes the concern, right? I mean, if I'm wearing pants that use nanotechnology so they don't wrinkle, that's not the same nanotechnology that can get into my tissue. So do you think that causes?
See, that's the thing. Is like if we make a pair of if we make a pair of pants and you wear them and it's against your skin, and can those nanoparticles get off and pass through your skin? Sure, they could. So we need to make sure that when we develop some new technology, that it doesn't come with it has a benefit, but it doesn't come with a built-in risk that makes the benefit null.
This guy's going to have a heart attack by the time.
Yeah. Or go ahead.
So some technologies are categorized by the U.S. government as something that we need to make sure don't fall into the hands of our enemies, and I'm wondering if there's any of that in nanotechnology, like ITAR regulations.
Nanoterrorism regulations. I really don't know, but I can tell you that we're developing nanotechnology-based bioterror sensors. She's telling me to stop. Can I have my daughter ask a question?
I'm confused. You said that it has to be controlled by someone, but if it's in your pants or in your sunscreen, it's not going to do anything once it's in your skin, right? Or is it just going to make your skin?
Well, we have to find out. That's the thing, is if they put nanoparticles in your sunscreen or in your pants or wherever, and they have to make sure that the hope is that the person who develops that product makes sure that those nanoparticles are not going to be bioreactive. They're going to be biocompatible, so that they're not going to hurt you. For example, if you put gold is a very biocompatible type of thing. And so if you make a gold nanoparticle, it can go into your system and go out of your system, and it's not going to have any bad reaction to you. But you would not want to put those beautifully colored quantum dots that were up there. They're made out of cadmium. You would not put those into a human being. You might take a piece of tissue out of a human being and use them to say, are there cancerous proteins evident in this tissue? And you could do something outside the body, and that would be very helpful. But you wouldn't want to put a toxic material into a person's body. So the idea is to understand both the risks and the benefits, and not and make sure that the benefit always outweighs the risk when you're using nanotech.